Okay, so now we're going to talk about where there are horizontal tangents on the curve, because these are curves, like I said, that are could have horizontal, or actually they could have vertical tangents. So if I go back to the derivative up here, the derivative equation, horizontal tangents would be where the derivative equals 0. And so on a fraction equation where the derivative equals 0 is where the numerator equals 0. So if I wanted to set negative 2x plus y over negative x plus 2y equal to 0, all I need to do is set the numerator equal to 0. So what happens with that then is if I get an expression where I get y equals 2x, that still is not answering my equation, but what it provides me with is a substitution for y. And so what I can now do with that substitution is I can go back to this original equation and solve for x, because I am going to swap out all my y's with a 2x. So I do that. I go back up to my original equation up here, and I rewrite x squared minus x times, instead of y, I'm going to write 2x, okay? So we see the x times y here, but now I know y equals 2x when the derivative is 0, plus y squared, so 2x squared equals 0. And, equals 7. We're looking at the original equation here. And let's solve for x. Okay, so you see here I have x squared minus 2x squared. If you square both things here, you get plus 4x squared equals 7. So I put that all together, and I get 1 minus 2 plus 4. I'd be solving now where 3x squared equals 7. So I divide both sides by 3, and then I would have to take both the square root, remembering that plus and minus has to be in front there. So x equals plus or minus the square root of 7 over 3. And then plugging back in for y, because we know that y equals 2x when the derivative is 0, we would have, if I put positive in these 2 points, the square root of 7 over 3, and the y value would be 2 times that, so 2 times the square root of 7 over 3 for my 1 point. And then my other point would be the opposite of that. So negative the square root 7 over 3 and negative 2 root 7 over 3. So they don't look pretty, but those would be the points if you would graph this equation where there would be horizontal tangents. And you always want to make sure that the points that exist on the original curve, and they do sometimes when we have fractions in there, we want to make sure they're not extraneous. One last thing, horizontal tangents, I'm not going to go through it for this problem, but we found horizontal tangents by setting the numerator to 0. Vertical tangents would be where there's an undefined slope. And think about this equation represents the slope. An undefined slope is when the denominator is 0. So for vertical tangents, you are setting the denominator of dy dx equal to 0. So in this specific problem, we would have set negative x plus 2y equal to 0. I'm going to write dot, 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 because the process after that, that's just algebra. But you do the same thing where you would substitute it back into the original equation.